So back with some more on conic sections. We're still talking about parabolas here. Remember, you can have a vertical parabola or you can have a horizontal parabola. We're talking about vertical parabolas right now. And I just want to label the parts of a parabola. So I want to start with the vertex. So the vertex of a parabola is where this thing goes from a downward and transitions to an upward graph. Okay, it's a transition point for this graph. So this point here would be called the vertex. Okay, and the vertex of the parabola has a line that goes through it, and that line is called the line of symmetry. Okay, so the vertex of the parabola will always have a line that goes through it. That is the line of symmetry. Okay, the line of symmetry. And a vertical parabola will have a vertical line of symmetry. And that means if you folded this on that dotted line, this side and this side would lay on top of each other. Okay? And that's an important line because it tells you where this thing goes from downward or decreasing to upward or increasing. A really good, important concept in calculus. So this particular parabola has a line of symmetry x equals 2, right? Vertical line at 2. Now, this horizontal line down here, this horizontal line is called the directrix. Okay? And the directrix is always perpendicular to the line of symmetry. Okay? It's always perpendicular to the line of symmetry. And then this point that's inside the parabola, this point right here, is called the focus. And the focus is a very important point in a parabola. Okay, the focus is any ray that comes into this parabola perpendicular to the directrix will bounce off the parabola and go to the focus. So if you ever see a satellite dish and it's got this little receiver sitting out in front of the dish, that receiver is at the focus, and all the satellite rays that come in bounce off and go to the focus. Same thing with headlights. You got a headlight here. All the rays from the headlight hit the mirror and go out in front of the car. So that's what the focus is used for. So it's really important to be able to find the focus. Okay? So something neat about the focus and the directrix. This distance from the vertex to the focus and this distance from the vertex to the directrix. So here, this green line, and here, this green line are both the letter P. P. Okay? The focus, I'm going to write this down for you. The focus is P units inside the parabola. Okay? P units inside the parabola. And the directrix, if I grab my paper and scoot it just a little bit, the directrix is P units outside the parabola. Okay, P units outside the parabola. So this distance P, okay, think of it like an absolute value. So if you know the vertex and you know P is 1, then this would be up 1 and this would be down 1. Okay, in this case, P is 1. Okay, so the big question is, how do we find P? How do we find P? Well, in our algebra classes, we had the formula for a parabola defined as A, x minus h, quantity squared, plus k, where A was our vertical stretch. And the easiest way, instead of learning something new, is to take what we know and modify it. This A term, okay, could be 1, 2, 5, 10, 1/2, 1/3, 1/5, 2/3, whatever. It's a stretch or a shrink in the vertical direction, okay? And P is equal to, because P is a distance, okay? P is a distance, okay? So keep that in mind. It's always going to be positive. P is equal to the absolute value of 1 over 4a. P is equal to the absolute value of 1 over 4a. And so if I know A is let's say 2. 4 times 2 is 8. P is 1/8. Okay, so very, very, very small p-value. What if A was 1/4? Well, 4 times 1/4 is 1, and 1 over 1 would be 1, so P would be 1. Okay, so that's how we find this. Now, we also have a horizontal parabola. Okay, notice the difference. We still have an A term, and that A term, right, can still tell us P. P is still the absolute value of 1 over 4A. The difference is we have x equals y squared. And when we have x equals y squared, we get a picture like this, a horizontal parabola. In a horizontal parabola, P will be a horizontal distance. So here's your vertex, there's P, there's P, there's your vertex. Okay, this vertical line is your directrix. Okay, your directrix. And there's your focus, right? That point right there, that's your focus. And your line of symmetry is going to go perpendicular to the directrix, and it goes through the vertex and through the focus. Okay, and it's going to have an equation. It's going to be y equals 2. The directrix is going to have an equation. It's going to be x equals -4 because it's a vertical line, right? And all of this stuff you should know from algebra. So we can write an equation for this. We can write an equation for this. And if we know the A value, we can find this distance and we can find this distance. So we're going to practice that. We're going to take this information and practice it, okay? So before we do that, I just want to talk for a second about applications of parabolas. Parabolas are used for a bunch of things. Speakers, headlights on your cars and your flashlights and anything like that. Satellite dishes. Okay, there's a lot of things that parabolas are used for, and so these are pretty useful things. So anyway, so let's move on. Let's try and find something. So given the following parabola, we want to find the vertex, the focus, the directrix, and the symmetry axis. Okay, so we want to find the vertex, the focus, the directrix, and the symmetry axis. Okay, so here is our parabola. And the secret here is that this parabola has been given in standard form. Well, do you notice everything we just defined kind of hinges on that vertex? So the first thing I want to do is put this in, pen's dried out because I sat here and talked too long. We want to put this in vertex form. Okay, we want to put this in vertex form. So, and we covered that in our last video, but basically we're going to start by dividing everything by 2. So divide by 2, divide by 2, divide by 2, and especially don't forget to divide your y or your f of x term by 2. So I get y over 2 equals x squared plus 5 halves x plus 4. I'm going to move this constant term over, and a lot of people will do that in the same step, but I like to leave it as 2 steps. So y by 2 minus 4 equals x squared plus 5 halves x. Now, we're going to take this guy, and we're going to find the magic number. I call it the magic number. This here is completing the square, what I'm about to do. I want to find the magic number that adds to this that makes it factorable. And the way we do that's really simple. We take this term, this b term, we divide it by 2. And 5 halves divided by 2 is 5 fourths. And I'm going to take that and square it. Okay? And that's going to give me plus 25 over 16. Okay, 5 over 4, 25 over 16. Over here, plus 25 over 16. Okay? And honestly, the hardest part now is adding that 4 to that 25 over 16. So anyway, especially since it's negative. But anyway, so let's work with the right-hand side. We're going to factor this. Okay, so we factor this down to x plus 5/4 quantity squared. And the fun part about this is if you don't believe me, you can actually say x plus 5/4 times x plus 5/4, and you'll get this trinomial right here. Okay, now, when I look at this number 4, my brain says the LCD is 16. That's 4 over 1. So I'm going to multiply by 16 over 16. So I get negative 64 over 16 plus 25 over 16, right? So that's going to be negative 39. That sounds right to me. I'm going to go with that. So we get y over 2 minus 39 over 16 equals that. Okay? So then our next step is we want to move this guy back over. Okay, so we do that. So we get y over 2 equals x plus 5/4 quantity squared plus 39 over 16. Okay? Last step is to multiply everything by 2. And commonly what happens here is someone will forget one of these. So times 2, and times 2, and that's going to turn into an 8. And our final answer for this, it's actually not even an answer because it's not what they ask us for, but it's going to help us find what they ask for, is 2x plus 5/4 quantity squared plus 39 over 8. Okay? And they want us to answer some questions. So the first thing I like to do is just in my head picture this parabola. And it's going to be upward. Okay? And I got the focus and the directrix, right? So here's the vertex. So the first question they ask is the vertex. They ask me the vertex. And the vertex is always going to be how far has this moved from the origin left or right, and how far has this moved from the origin up or down. Well, this shifts the function to the left. So the vertex will be negative 5/4, right, left and up. So comma 39/8. That is your vertex. There's your first question answered, the vertex. Okay. The second question they ask is the focus. Well, to find the focus, I need to know P. Remember, this distance here and this distance here, and I'll go ahead and label those in a color. Okay. They're both P. P. So this is P units up, and this is P units down. Well, since they go up and down, they're going to affect the y value. Okay? Since P goes up and down, it's going to affect the y value. So I got to find P, right? Well, come back up here to our equation. A equals 2. A equals 2. Well, P is equal to 1 over 4A. Absolute value. Okay, so put that here. 2 times 4 is 8. So P equals 1/8. P equals 1/8. Okay, so what can we do with that? The focus is going to be the vertex plus up 1/8. So negative 5/4, comma 39/8, and I'm going to add 1/8 to the y value. add 1/8 to the y value, and that gets me a focus of -5/4, comma, and 39/8 plus 1/8 is 40/8. Just jot that down, 40/8. But you know you better not give your math teacher 40/8 because that reduces, right? That's something like 20/4, but then that reduces to something like 10/2, which ends up actually being a really pretty number. It ends up being 5. Okay, so the focus is -5/4, comma, 5. That point is just a hair up from the vertex. Well, the directrix is going to be the same thing, except instead of going up 1/8, it's going to go down 1/8. So instead of saying 39 plus 1, I'm going to say 39 minus 1. Well, 39 minus 1 is 38/8. And it's going to affect the y value because it went down from the vertex. So this is going to be -5/4. And again, you have to reduce this. Well, 38/8 is something like 19/4. And I don't think it reduces past that. So this will be 19/4. If it reduces more than that, I don't see it. Okay? So here we go. The directrix. So we found the directrix. What's the last thing I asked for? The axis of symmetry. The symmetry axis. Well, the symmetry axis is a, you know what? Sorry. The directrix is not a point. You can scratch that. The directrix is not a point. The directrix is a line. It's a horizontal line. And so I need to write that as a horizontal line, which is y equals 19/4. That's what happens when you make videos late at night. You forget simple things. The directrix is a horizontal line, so we have to write the equation of a horizontal line. Y equals 19/4. All right, so the symmetry axis, going back to this same concept, is a vertical line, and it goes through the vertex. Well, what's the equation of a vertical line? The equation of a vertical line is always x equals a number. Well, if you look at your vertex, there's the value of x. And so the symmetry axis is going to be x equals -5/4. Okay? So that's everything you could possibly be asked about a parabola. Put it in vertex form, find the vertex, maybe sketch the graph, find the focus, find the directrix, find the symmetry axis. Okay? So if you have questions about this one, let me know. I'm going to do one more just to add to this. So one more question here. The same questions. I want you to find the vertex. I want you to find the focus. I want you to find the directrix. And I want you to find the axis of symmetry. Okay, so find these 4 things given this equation. Okay, well, the first thing you got to notice is this says x equals y squared. So what's it going to look like? It's going to look like that. That's important because that means your directrix is a vertical line, and your line of symmetry is a horizontal line. So these equations will change from our previous example. But let's start with the vertex. Well, we know this thing has been moved, so it's y plus 3 quantity squared. Since this is grouped with y, it's backwards. So it's been moved down 3 and to the right 5. So the vertex will be at 5, -3. And that's that point right there. Well, where's the focus going to be? The focus is going to be inside the parabola. So this is moved in the x direction. So who's it going to affect? It's going to affect that 5. Well, this here is A. A equals 1/8. Well, what's P equal to? P is equal to 1/4A. Well, 4 times 1/8 is 1/2. And 1 divided by 1/2 is 2. So this distance from here to here is 2 units in the x direction. So if this is 5 and I move 2 units to the right, this is 7, -3, because it didn't move up or down, it only moved to the right. Okay? Well, if this is 2 units to the right, where's the directrix? 2 units to the left. So the directrix is going to be a vertical line that's 2 units to the left of this. And that's going to be x equals 3. And then last but not least, the symmetry axis. The symmetry axis is going to be a horizontal line through this point. And the equation for horizontal line is y equals, and if I look at my vertex, this is x, this is y. What does y equal? Okay, -3. Okay, so what's the difference in these two examples? Sometimes you're given vertex form, and when that happens, you don't have to convert it. Most of my work from the previous example was actually converting this problem to vertex form to answer these questions. So anyway, there's our common questions for parabolas. What is P? What is the vertex? What is the focus? What is the directrix? And what is the symmetry axis? If you have any questions, let me know.